If it is 4 hours, not too bad.
Yes.
All right. Leila, ready for class?
And what?
Are you ready for class?
Yeah.
Nigar, how about you? Are you solving a problem?
No, I'm here too. I'm looking for my notebook.
You're looking for your notebook or
Yeah.
at your notebook?
No, at my notebook.
I mean, are you looking for your notebook or are you looking at your
No,
notebook?
I'm looking
Huh?
for notebook.
You're looking for your notebook.
Yes.
Did you find it then?
No. Now I'm finding it.
Okay. Elmira, are you here?
Yes.
Elmira, why we cannot see your face? Do you make this on purpose because it's so dark and we cannot even, I can only see your glasses. Okay, now I can see your face. Very good. Where is Ilkin? Ilkin, are you here? Where is Ilkin? Ilkin is absent today. Maybe he will join soon. All right, Leila, Nigar, Elmira, Mariam, and who else? Anybody else here?
I'm here too.
Sarah, and okay, guys, good to see you again. Nigar, how is your math at school and here? Which one is harder? Which one is more difficult?
Now here in this lessons because for example geometry, we haven't got any geometry in school now in 6th grade, and it is harder than school.
What are you studying right now at school in math? Did you have math class today?
Yes, I had and we had, it's not as a test, but some exercises, and
So you just did revision. You didn't study any particular topic.
yes, and we're teaching, not teaching, we're learning equations.
Equations. That's good. That's good news. Actually, if you are good at equations, then we can solve every problem. Good, guys. Let's continue then. As you know, we have just started this, and that is our last day. I don't know. We spent 4 hours for this test, but the most important thing is understanding. Okay, when you just read the problem, do you understand quickly, and how fast can you understand the question? That is what we are trying to learn here. And because once you understand the problem, solving is much, much easier. Okay, today is 18, I think. And a few questions were left from this exercise. As you remember, we did until question 17, I think. Yes, we stopped here. That's the last question. And it was a little bit harder. As I told you, out of these 25 questions, starting from 16, right? 16 to 25 questions are quite harder. And 1 to 15, they are, let's say, short answer required questions, so you can just solve it in 1 or 2 steps. Okay, now let's continue from this question. That's also a little bit tricky question. Leila, can you read the question?
Yes.
Read the question, Leila. Leila, read
Find
the
the
question.
total find the total number of triangles in the diagram.
Okay. And now, guys, you are familiar with this type of questions, right? What do they mean by asking this question? How many triangles are there, right? We need to just count all the different triangles here. And what do you think, Elmira? How should we count the number of triangles here? Can you just tell me the methods, just the idea? How can we count this so that we can get the right answer? And, or if I ask Elmira like this, okay, now the question is clear. We need to find the number of triangles here, right? How would you count this triangle? Can you just tell me the method you are going to use here?
Yes, I can just count, but I can also put like A, B, C, yes, A, B, C, D, and count like every triangle, like from A to B, from C, for example.
Okay. So now we are going to do this in two different ways. Okay, first let's just label, okay, and after that you will count and we will compare the answers. One way is, let me just tell you the method. Let me just label the vertices of this polygon, not polygon actually, it's a kind of figure. This one is B, this one is C, this one is D, this one is E, and this one is F, and this one is G, and this one is H, right? So number one, okay, can you just count the triangles where one of the vertices is A, okay? And after that, count the triangles where one of the vertices is B. And in this way, one of the vertices it is C, and the D, and the E, and the F, and the G, and the H, right? And after we just count them together, we will get the total number. Okay. So now let's start with A. Leila, can you count here how many triangles we have? Guys, let's do this question all together, okay? And I'll ask you the next question. I'll give you some time. And Leila, Nigar, you will count the triangles where one of the vertices is B, Elmira, the C, Mariam, D, and who else? Sarah, E, okay. Leila, let's start with you. How many triangles can you see here where one of the vertices is A?
A is first, then A, B, and G.
Like, for example, ABF. I don't have to write, but just for this, let me write here. ABF, it is one, right? And how about
Yes.
ABG? Another one. ABC, another triangle. And AE and AFE, another triangle. Okay, so now just like this, we have to count this. Now let me just write the answer here. Let's count together. ABF, 1, right? And ABG, it is 2. ABC, it is 3. AEF, it is 4. AEG, it is 5. AEC, it is 6, right? And do we have more?
ACE.
Can we say ABE?
Okay.
Yes, ABE.
A
A.
Yes, let me count one by one. Okay, so just listen to carefully so we don't get confused. Otherwise, ABF, okay, 1. ABG and ABC, it is 1, right? And after that, AEF, it is 1. AEB, it is another 1. AEG, it is another 1. AEC, it is another 1, right? And is that all? Can anybody see more than 6, 7? It is 3. It is 4. Is it only 7? Okay, it is 7. All right, now A is gone. Okay, 1, 2, 1, 2, 3, 4, 5, 6, and 7, and that's it. Okay, 7. And how about the triangles where one of the vertices is B? So it is BFG 1, BGC 2, BFC it is 3, BEG it is 4, BEH it is 5, BED it is 6, BDC it is 7. All right, guys, let me just count it in different way. This is also okay, but somehow if I write one by one, I can do this. That is one method, just keep it in mind. Let's do like this. Let's count the triangles which contains only one part. Okay. And the triangles which contains two parts, and the three parts, and the four parts, and maybe five parts, and six parts, and seven parts, blah, blah, blah. Okay. Uh, how many triangles do we have that has only one part, right? It is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? All of this triangle actually they have only one part, one region, one triangle. So here we have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9. Okay, done. Now we will count the triangles actually which consist of two triangles or two regions. And this one is 1, right? Two regions. And this one is 2. And this one is 3. This one is 4. This one is 5. And this one is 6, right? This one is 6. And this one is 7. And this one is 8. And this one is 9. And this one is 10. And that's it. We have 10. Okay, good. Now, how about if it's three parts? Three parts is, for example, here we have 1, right? That contains three parts. 1. And here, for example, this one, 1, 2, 3. This is also number 1. It is 2. And this one is 3, right? And there's three parts. This one, 4, right? And there's three parts. That's it. We have 4, right? How about four parts? 1, 2, 3, 4. This one is one triangle that contains four parts. And 1, 2, 3, 4 that contains four parts. Right? And that's it. I think we have 2. Sarah, what do you think? Do we have any triangle that contains 5 triangles?
Mm, no, I can't see.
No, right?
I
But I
saw
think yes.
where?
Which one?
Ah,
And
yes, yes, I saw. Yes. Can I say?
Yes. Is it BEC?
Yes, yes.
Okay, BEC. We have one, right? BEC. As you see here, it contains 5 parts, 5 regions, right? So we have one. Only one. How about 6 parts? No more, right? Okay, I think that's it, guys. Okay, it is 19, 23, 25, 26. Is it 26? Can anybody find more than 26? Okay, you can try this. I think that much is enough. That's the idea here. Just we need to count in a systematic way. Okay, the triangles, which actually consist of only one triangle, triangles, two contains two triangles, and 3 and 4 and 5. In this way, I think we can count much faster. So the answer is 26. All right. Elmira, read the next question.
a teacher has a bag of sweets to treat her class. If she gave 5 sweets to each student, then she would have 13 sweets left. If she gave 8 sweets to each student, then she would have 20 sweets, 12, 20 sweets short. How many students and how many sweets are there?
Jos, you have 2 minutes. Think, okay? I just want to see how can you solve this question. Any answer? Mariam, how I wonder how you are solving it. Just thinking, or are you? Did you form an equation?
Yes, I tried to solve it with equation, but I think my equation is not right.
What's your first equation? Can you tell me?
I think that if we suppose that um, her class, teacher's class is x, then we minus from x 5 multiplied by y, and it's equal to 13. So 13 sweets left.
Mariam, if I just ask you one question, okay.
Mhm.
Suppose in the class we have how many students, right? Number of students, let's say we have m,
X.
okay. Or x or y, doesn't matter. But usually if you're talking about whole numbers, you better use m or n. Any number at the time you can use x. So suppose how many sweets in the back, let's say we have n sweets. Okay. Now, what is our first equation? If you read this, if she gave 5 sweets to each student, then she would have 13 sweets left. What equation would you write to the first sentence?
N minus 5 uh, equals 13. Or
No, we are distributing n sweets, right? And
yes.
among m students, each one receives 5 students, and still we have 13 sweets left. This 13 sweets left, what is it?
Mr. Kasim.
Our answer.
It's a
Yes,
remainder.
13
It's a
remaining.
remainder. It's a remainder. So
Yes.
how do you write this then? Number of sweets n is equal to 5 times m, right? M students, each one receives 5, but still we have 13 students. In the second one, it says that if she gave 8 sweets to each student, then she would have 20 sweets short. So n sweets, now each student receives 8. How many students? M. But still we need more sweets. How many more? It is 20 more
Minus
sweets.
20.
That is our equations.
Mhm.
Yes, Elmira, did you say something? 68 what?
Yes, I saw like that.
68, what is it? The number of sweets or,
Yes, sweets.
and what is 33?
It's students. Yes. Yes,
Elmira,
students.
Elmira, how can we have 33 students? If 33 students, each one receives 5 sweets, that means that actually you need to give 165 sweets, right?
Mm.
Okay. Okay, that's the most important thing. It's about actually one thing is, for example, if you divide 17 by 5, for example, the quotient is 3 and the remainder is 2. How can I write this as an equation? That means that 17 is equal to 5 times 3 plus 2. 2 is a remainder here. So now if you look at these equations, Leila also, you gave me so beautiful answers. How they get those numbers so big? So n, and also left hand side n, right? Which means that also the right hand sides must be equal to each other. That means that 8m minus 20 should be equal to 5m plus 13. So now how do you solve this equation? It's very easy, right? Take this to the left hand side. 8m minus 5m. Take 20 to the right hand side. 20 plus 13. 8m minus 5m, that's equal to 3m. 20 plus 13, that's equal to 33. Then what is m? M equals 33 over 3, that's equal to 11. So that means that in the class we have 11 students. And now how do you find the number of sweets? Either using the first equation or the second equation, we can get the value of m. If you use the first one, 5 times m, m is 11 plus 13. So it is 68. Elmira, your answer is, Elmira, actually 33. Did you make a mistake here? You didn't divide by 3.
Yes, I divide by 3, but I say 33 instead of 11.
11. Okay. If
Yes,
you saw like this, Elmira, then it is correct. Very good.
thank you.
Okay, Nigar, is everything clear?
Yes, now I understood this method.
Good. Who can tell me the answer without doing anything? Can you just do this answer? Can you do this mentally without writing anything on the paper? Without writing anything on the paper, can you calculate it? You get right too.
Because in numerator, no, we have, for example, mm, so we have this numbers as 2 2 or 3 3, yes, in numerator. Am I right?
No. You
So
got.
no,
I think did we ever solve this kind of question before with you?
about plotting and yes, but about
Yeah, this
multiplying,
similar question. Did we ever solve?
Yes,
yes,
a lot of times.
So why did you forget so quickly then? Elmira, how did you get your answer?
Yeah, for example, if they're 2 and 2, we can like left them and there
yes,
will be left only 1 over 1 and 1 over 2014. And if we like plus it, I think we will get 1 over 1 means 1 and 1 over 2040.
Okay.
Mm,
Good, guys, let's continue one more time. I will do this, okay? Here, the difference between these two numbers, it is 1, right? So, as you see here, if you just take this observation, 1 minus 1 over 2, what is it? Is equal to 1 over 2. You know how to subtract fractions, right? 1 over 2 minus 1 over 3, what is it? It is common denominator 6. 3 minus 2 over 2 times 3, that's equal to 1 over 2 times 3. And also like this, 1 over 3 minus 1 over 4, that's equal to 1 over 3 times 4. And 1 over 2013 minus 1 over 2014, that's equal to 1 over 2013 times 2014. Now, instead of this number, suppose that this sum is equal to S. I'm going to find the value of S. So S is equal to, instead of 1 over 1 times 2, whose answer is it? Layla? No, it is not correct. So instead of 1 over 1 over 1 times 2, I can write what? 1 minus 1 over 2. Plus, instead of 1 over 2 times 3, I can write this difference, right? That is 1 over 2 minus 1 over 3. Plus, instead of 1 over 3 times 4, I can write 1 over 3 minus 1 over 4. And this continues, right, until the last one, 1 over 2013 minus 1 over 2014. So, Miss Leila, what is negative half plus positive half? What is their sum? It is 0, right? Minus 1 over 2 plus 1 over 2, it is 0. Minus 1 over 3 plus 1 over 3, it is 0. Minus 4 over 4, next one will be also 0 because we see the pattern here. And also this one and this one, it will be equal to 0. Only the first number and the last number, they don't have any pair. So now what we have here then? 1 minus 1 over 2014. So now how do you subtract this? 1, I can write it as 2014 over 2014 minus 1 over 2014. So now denominators are the same, 2014 minus 1. So that is 2013 over 2014. Nigar, did you understand?
yes, but
Are you sure?
yes,
If so, I will ask another question then. Immediately, I will copy this. Okay, maybe if you have done this before, there's a new question for you. Okay. Guys, you have 2 minutes. Okay, solve this question. Sarah, do you have any answer?
Mm,
No
me?
or yes?
No.
Leila, how about you?
I have, and I'm not sending you. Sending.
Elmira, Nigar, Mariam, did you get anything? Why are you spending too much time?
Yes, I get um some answer. I'm
Some
not
answer?
sure.
Really? Not sure or?
I'm not sure. Yes.
Oh, yeah, 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 yeah. Elmira, how about you? Any answer? I got one answer from Leila, but it's not a correct answer.
But I said I'm not sure.
Hmm? Say again, Nigar.
I'm not sure also.
Why not sure? Why?
I don't know.
How did you get? Could you write this fraction as a difference of two fractions? How did you write it? Like for example, 1/1 times 3. Could you write it as a difference of two fractions?
Yes.
Like
Sure.
for example, let's say 1 minus 1/3, right? What is it? It is 3/3 minus 1/3. 3 minus 1, it is 2/2 times 3, right? But here we have 1/1 times 3. How can I eliminate this 2? To eliminate this 2, how about if I just check this answer, this one? 2 times, not 2, 1/2 times 1 minus 1/3. So that's equal to 1/2. And we have already subtracted. That's equal to 2/2 times 3. Now this 2 cancels each other. That's equal to 1/2 times, why am I writing 2 times 3? It is 1 times 3, right? 1 times 3. So that is 1 times 3. Let me just check. I have one answer. Leila, no, that's not correct. Okay. Because Jules here, the difference is not 1, it is 2. This also the difference is 2. That's why, as you see here, 2 appears in the numerator. To eliminate this 2, I'm just dividing by multiplying by 1 over 2. So now if you check this, for example, 1 over 2 times 1 over 3 minus 1 over 5. What is it? 1 over 2 times, and 3 times 5, right? The common denominator. Here I have 5 minus 3. What is 5 minus 3? It is 2, right? This 2, they cancel each other. That's equal to 1 over 3 times 5. In general, let me just write that thing, okay? Here, 1 over m times m plus k. The difference is k, right? So we can write it as 1 over k times 1 over m minus 1 over m plus k. Okay, I'm just going to use this thing. So now I think you got the idea. Also, the last one, 2019 times 2021, I can write it as 1 over 2 times 1 over 2019 minus 1 over 2021. So which is equal to 1 over 2019 times 2021. Now, let's say we are going to find this sum, right? That's equal to, let's say, S. Then what is S? The first fraction, I can write it 1 over 2 times 1 minus 1 over 3. Plus the second fraction, 1 over 2 times 1 over 3 minus 1 over 5. Plus the third fraction, I can write 1 over 2 times 1 over 5 minus 1 over 7. Plus the last one, 1 over 2 times 1 over 2019 minus 1 over 2021. Ay, ay, ay. Nigar, what is the common factor? Do you know what is common factor? Do they have any common factor?
Hmm,
Can
I
you see this
think
1 over 2?
yes.
Here we have 1 over 2. Here we have 1 over 2. Here we have 1 over 2. In front of every difference of fractions, we have 1 over 2, right? Can I just take this out and write here? Like,
Yes.
did you study this one at school? For example, let's say a times x plus a times y. This a is a common factor. I can take this out, right? And that's x plus y. Very simple formula. So as you see here, 1 over 2 is a common factor. Inside, what we have here now? The first one is 1 minus 1 over 3. The second one is 1 over 3 minus 1 over 5. Third one is 1 over 5 minus 1 over 7, dot, dot. And the last one is 1 over 2019 minus 1 over 2021. So now, as you see here, again, these two things is equal to 0, right? And these two things is equal to 0. These two things, they are equal to 0, and also this one equal to 0. So what we have here, 1 over 2 times 1 minus 1 over 2021, which is equal to 2020 over 2021. And now if you simplify this, 2020 over 2, that is 1010 over 2021. That is the answer. Elmira, did you understand?
Yes, but I have to think more time.
Long time? How many years?
More. No,
More time.
yeah.
I
Yes.
see. Now, girls, I'm going to ask you one more question. Very similar. Just if you try to understand this thing, all right, this formula. And the last question, I'll just ask you one more question. Let's see. Can you do that or not? Because when you practice more and more, you understand much better. Okay, and how about this one? Can you do this question? Idea, everything is the same, but just numbers are a little bit different. You have 2 minutes.
Sorry, Mr. Kassim, it is not. It is not my answer.
Yeah, why did you simplify your answer? Numerator and denominator is divisible by 4, right?
Yes.
You should always leave your answer in the simplest form. Elmira, really? Okay. Guys, again, one thing, again, actually, if you just practice me again and again, you have more and more idea about this methods. Okay. Nigar, are you sure, Nigar?
No.
55 or 505?
1 second.
Yeah, if you divide 2020 by 4, it is 504, right? I mean, 5, right?
Oh, yes, I'm sorry.
Good. Okay. Guys, if you just continue, if we take this number as, for example, m, right? And next number as a c is just m plus 5. So now how do you write this? Again, this 1 over m times m plus 5 is equal to, and again, here we have 1 over k, that's 5. And here we have 1 over m minus 1 over m plus 5. So as you see here, if you simplify what we have here, 1 over 5, common denominator is m times m plus 5. And here we have m plus 5 minus m. This m, they cancel each other, and 5 cancels each other. That's equal to 1 over m times m plus 5, right? The left-hand side. So now, because the difference is 5. Okay, one more time. Let me just check this. Layla. Okay, Layla, let's see, Layla. Let's see. Now, again, let's say we are going to find this s. So each time, actually, we have 1 over 5 in front of the difference of these fractions. 1 over 5, okay? Let me just take this all out because every fraction has a common, the common factor. The first one is, what is it? 1 over 5 minus 1 over 10. Plus, next one is 1 over 10 minus 1 over 15. Next one is 1 over 15 minus 1 over 20. Dot, dot. The last one is 1 over 2015 minus 1 over 2020. Now, if you look at these fractions, right, these two, the same but opposite signs. and also this 2, and also this 2, right? And also this 2. Only actually the first and the last one is left. So here we have 1 over 5 times, here we have 1 over 5 minus 1 over 2020. And what is the common denominator? Here, the common denominator is 2020. And the first fraction, right? I need to multiply by, what is it? 404, right? Because 5 times 404, that's equal to 2020, right? It is 2020. So here we have, what is it? By 404. So here we have 404 minus 1, okay? Which is equal to 404 minus 1, that's equal to 403 over 5 times 2020, that's equal to 10,100. That is the answer. Whose answer is like this? Hmm? Leila, your answer is 1 over 10,100, but it's not 1 over, it's 403 over this. Nigar, do you understand a little bit more, but still not so clear? Okay, as Elmira said, I think you need some more time to think about this, okay? But actually, it's very, very easy thing. Maybe we're talking about a lot of numbers. That's why it may be a little bit confusing right now. As you practice 2, 3 questions, you'll understand that it's very easy. Now, let's move to the next question. We have just 9 minutes left. Okay. Nigar, can you read the question?
Yes, Yuzi has 23 coins. She divides them into 5 piles so that each pile has a different number of coins. Find the smallest possible number of coins in the biggest pile.
First thing, okay, you have 90 seconds, and after that, we will discuss together. It's also a very easy question, not so complicated.
90 seconds or minutes?
90 seconds, 1 minute and 30 seconds.
Oh.
Mariam, how are you solving this question? Can you tell me?
I think that so she divided them into 5 piles. So maybe we can divide 23 by 5, and we got 4, right? So maybe 4 is the biggest pile, and smallest possible number, I think.
Okay. Here, I think you understand the question. We have 23 coins, and we are making, what is it? 5 different files. And not files, like piles. Piles means we are just stacking these coins, right? Leila says 7. Leila, are you sure? But your answer is correct, Leila. So let's say that's the biggest pile, and that B is the second biggest pile, and C is the third biggest pile, and the D and E, because it says that so that each pile has a different number, right? None of 2 piles can have the same number of coins. Okay. So now if I just start with the biggest one, suppose that it is 5. If it is 5, B must have then 4. It must be less than 8, right? It is 3, and it is 2, it is 1. Then how many coins do we have here? 5 plus 4, 9, 9 plus 3, 12, 12 plus 3, it is 15. But actually still we have 7, 8 more coins. It doesn't work. And how about the biggest one is 6? At the time, maybe it is 5, then it is 4, it is 3. Maybe the smallest one, it can be 2 or 1. Let's say it is 2. At the time here we have 11, 15, right? Now we have 20, right? So still it doesn't work, right? So I need 3 more. Where can I add? I cannot add anywhere. Only I can add here the biggest one, right? So if I add here, let's say 1 more, it is 7. So it can be 6, 13. It can be 5. It is 18. It can be 4, 22. Then here we have 1. Altogether, how many now? It is 23. Because when actually the biggest pile contains 5 coins, it is not possible. When it has actually 6 coins, also it is not possible. So when it is 7, right, it is possible. So that is the smallest possible number of coins in the biggest pile that we can arrange. So the answer is 7. Next question. Guys, you have again 1.5 minutes, okay? And let's discuss this and we'll see. Exactly, you have 105 seconds. I just want to know, can you just see the rule or not, okay? Water? I need water. Leila, what's your answer? Just guess, because your guesswork works very well, you know. What's your answer? Tell me.
No, I don't have answer, but I'm
Just
told.
tell me one answer. Just tell me one number, Leila. Just tell me one number. What do you think? What do you feel about the answer? Tell me, come on. Leila, tell me one number.
I don't know.
Just tell me one number. Come on, just guess. Guess.
Okay. 4.
That's the correct answer. That is the correct answer. The answer is 4. You see, Leila, in the exam, I think if you guess, I think you can get the gold medal. If you guess what works well there. Nigar says 4, 7. What do you mean, Nigar? You should tell only one answer, right?
Oh, only so it is 4, and then after 4, 7.
Okay,
And then,
good. Sarah says 4. Sarah corrects. Leila says 7. It is not correct. Okay, that is correct. But actually, about the rule, what is the rule here? The rule is
7 is older answer.
7 is what?
It is not this question answer.
7 is the next number, right? If I continue.
Yeah.
Anyway, what is the rule here? Nigar, what is the rule here? I mean, how did you get 4? How did you get 7?
I was guessing because at the first I thought that 1497 and then 7941. So whereas the removing numbers, no, that's from 1 till 7 and then from 7 till 1. But
Okay,
then
maybe your guesswork works here, actually, luckily, but actually here, how we are writing this number, we are squaring the natural numbers. Like 1 squared, it is 1. The sum of the digits, it's 1. 2 squared, it is 4. The sum of the digits, it is 4. 3 squared, it is 9. The sum of the digits, it is 9. And 4 squared, it is 16. The sum of the digits, 1 plus 6, that is 7. And 5 squared, 25. The sum of the digits, it is 7. And the 6 squared, it is 36. The sum of the digits, it is 9. And how about if you continue this, okay, if you understand this idea, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this one is 11, right? So 11 squared here, it is 121. And what is the sum of the digits? It is 1 plus 2 plus 1. That's equal to 4. Next one will be 12 squared. That's equal to 144. The sum of the digits, 1 plus 4 plus 4. The next digit is, what is it? It is 9. And next digit will be 13 squared, 169. So that is 1 plus 6 plus 9. It is, what is it? It is 16, right? But 16 is a 2-digit number. I should continue adding the digits. 1 plus 6, that's equal to 7. And after 9, it will be 7. Okay, guys, unfortunately, we couldn't finish this. I thought we could finish this today, but again, no problem. 3 more questions. We will finish next week. Okay, so let me see. Okay, if you need more questions to practice, let me know. Okay, if you think that you need it, I will send it. But if you think you don't need it, I don't want to share any paper with you. If you think, Mr. Custom, I need more questions to practice, just let me know in WhatsApp. I will give you new paper. Okay. Thank you very much. Have a nice weekend. All right. See you next week, guys. Now, other group is waiting for you. I have to finish this meeting. Okay.
Goodbye. Thank you.
Bye
Okay, bye
bye.
bye.
Bye bye. Thank you.
Thank
Have a
you.
nice weekend.
thank you, goodbye.
Bye bye.
Bye bye.
Bye bye, Leila.